Good morning, everyone. So in this video, I'm going to talk to you about one of the very recent and controversial issue surrounding the use of p-values or statistical significance and the use of stars that you often see in any published literature. People use 1 star, 2 star, 3 star corresponding to 10% level of significance, 5% level of significance, and 1% level of significance. There is a lot of debate going on in the academia that over reliance on statistical significance is not a good thing. So while trying to give too much emphasis on statistical significance, we are forgetting the economic significance of our results, and it is leading to many of the associated issues that I'm going to talk to you about in this video. And at the end of the video, I'll show you one paper which do a really good job in navigating through this and which incorporates many of the suggestions that are there to overcome the issues surrounding the use of statistical hypothesis testing. To start with, what is the controversy all about? So the major issue that we have come across related to the hypothesis testing or statistical significance, whatever way you want to call it, is that by giving overemphasis on statistical hypothesis testing, we are ignoring the economic significance. So what happens is when you see any published paper in social science or economics or any other subjects, from abstract to conclusion, you will see the word significance being used very liberally without distinguishing the economic significance from statistical significance. And people only talk about those variables which are statistically significant in that arbitrary 5% level of significance or 10% level of significance. And they often interpret only the signs. So this is classically being termed as sign econometrics. For example, I'm trying to understand what are the different variables which affect the adoption of a technology, and you find that education is one, and then extension contact is one, and both have a positive sign. And people simply talk about education positively affects adoption, extension contact positively affects the adoption, because those two variables are statistically significant. And this is called as sign econometrics, because except the direction of impact or direction of influence, you never talk about the magnitude. And often this is not a really interesting thing to do. And from a policy perspective, it's not really useful unless you're doing something very new and you're contributing to the literature. You're the first person to first researcher to explore that particular dimension. Unless you're doing that, sign econometrics is often very boring and not really useful. I'll also give you one more example. Suppose you are trying to estimate the impact of adoption of a technology on income, and you do all this fancy econometric modeling like propensity score matching or DID or RCT or something, and when you get the results, your results are statistically significant, say at 5%, and you just give all these conclusions and policy implications that the adoption of this technology leads to a higher income and government should support this and all this, by only looking at statistical significance and never really talking about the economic significance. What do I mean by economic significance? Economic significance means how big is the impact. If you find the impact is just, say, 200 rupees, and the adopters on an average got 200 rupees more income than the non-adopters of the technology, does it really matter? Is statistical significance really important in this case? What you should be talking about is the economic significance, how big the effect is, right? So this is one major issue that we are seeing in many of the published literature. Second major controversy or the issue surrounding the use of p-value is that people resort to what is called as p-hacking. Um, they run hundreds of different specifications of the model, and all they are looking is that magical figure of t-test value of 1.96 plus or minus, which means the p-value is less than 0.05 and it becomes statistically significant, and then they can report it in the journals. So this is called as p-value hacking, which is kind of unethical practice or non-transparent way of doing research. Instead of going with the best possible model according to all the theories and all other stuffs, or based on your understanding of the subject, you are fishing for a model which gives the most ideal p values according to you and the statistical significance, so that it becomes easier for you to publish the journals. So going for overemphasis on statistical significance has led to publication bias, wherein the studies which report statistical non-significant results are often difficult to publish, right? This is not just the issue with the journals, that journals are often not interested in publishing results where the results are statistically non-significant. It is also the issue with the researcher. There is a hypothesis that researcher often loses interest if the results are statistically non-significant, and those papers are often written very badly. So these are the major issues with respect to overuse of statistical significance. But there is another side of the issue, which is wrong interpretation of this statistical significance. So often we are not really well taught about the philosophies behind the hypothesis testing and what is the correct way of using the p-values or t-test or hypothesis testing. So what happens is, in many of the papers that I see, if a particular variable is statistically non-significant, people tend to make wrong claims about it. Absence of evidence is not evidence of absence. Just because one variable in your model using your data is statistically not significant, it doesn't mean that the theory is wrong. It doesn't mean that the intervention for which you are assessing impact has no impact. It is just that you did not find the evidence to support your hypothesis. So this is one major issue. And second thing is, to use this hypothesis testing, it depends on what kind of null hypothesis you have, right? And also it depends on many assumptions on how the data is generated, how the data is collected. It is always based on those conditions that your interpretations rest. So you should clearly understand what are those assumptions and how to interpret the statistical significant results appropriately. Also, there is a claim that this 5%, 10%, 1% levels that we often use, they are very arbitrary. Those levels are very arbitrary because a simple fact that t-test values are calculated with standard errors in the denominator, right? So if the sample size increases, the standard errors often falls. So if your data set is really large, then most of the variables that you include in the model turn out to be significant, statistically significant. I shouldn't be using the term significant vaguely without distinction between statistical and economic significance. So meaning that if your sample size is large enough, then most variable will turn out to be significant, statistically significant, if you are using an arbitrary cutoff of, say, 5% level of significance. So these are the kind of the major arguments against the overuse of p-values in scientific reporting. So what is the solution? What should we be doing ideally in an idealistic world? So the first thing is, do not use the word significance arbitrarily. So if you are referring to statistical significance, clearly mention that it is statistically significant at what level of significance, and write it clearly. Second thing is, since this 5%, 10%, 1% level of significance is very arbitrary, rather it is better to report the continuous p-values, also the confidence intervals, and do not use the stars unless and until the reviewers or the editors or the journal demands it. Avoid using those arbitrary 1%, 3 or 2%, I mean 1 star, 2 star, and 3 star in reporting the results of your statistical analysis. And the major takeaway from this talk, if I want you to take one message out of this video, then it would be that you should always spend more time in explaining the effects, not just the sign. Do away with sign econometrics. Try to interpret the size of the effect in a way which is useful for those who are reading it and also for policymakers. Give it a context, report the effect sizes, the economic effect sizes properly. So, and also don't just rely on point estimates. It's always better to give confidence interval, or it's also called as sometimes called as compatibility intervals. And these are the some of the things which you can do to improve the reporting of the scientific literature. So when I talk about all those things, so many people ask, like, but if I look at any journal article, most journal articles do only these things, which means they always give stars, they always talk about the statistical significance from abstract to conclusion. Can you show us one paper which do all these things really well? So I have one such example which I want to show it to you today. So I hope you can see the paper now. So this paper is titled "Is Animal Welfare Better in Small Dairy Farms?" authored by Lindena and Hess. So a recent paper published in 2023, 22. So in this paper, I'll talk through it in some of the important things which I mentioned in my talk. So I don't want to read the entire abstract right now in front of you. I'll share the link to this paper in the description. You can download and read the abstract. It's really well written. But the point I want to emphasize right now is, see how they talk about the size of the effect. The effect size was small. They never talk about significance in the abstract, right? They do not arbitrarily use the term significance, right? They always emphasize is on what you can call economic significance. That means how big the effect is or how small the effect is, right? And it is always contextualized, right? It is always contextualized. Then I'll directly go into okay, I don't want to spend much time on all this. I just want you to look at the results. Okay, I hope you can see the results now. So look at the results, the tables in which the results are given. They provide p-value, right? They provide 95% confidence interval or compatibility interval. They provide the effect sizes or the coefficients. You cannot see any stars here, right? Then I'll move on to how they write about the results. Okay, so if you see in this section, so they clearly interpret the economic significance of the result. So this paper deals with the effect of herd size on animal welfare. So 1% larger than average dairy farm, I mean size of the farm, it results in 0.0069 increase in the animal welfare indicator. They also write about ceteris paribus, which means other things being equal. Then they talk about 10% more herd size. Then they talk about a heart size which is 100% more than the mean heart size in the sample. And then they talk about how big the effect is. Then they give that statement that the effect size therefore is very small, because even if the heart size is twice larger than the average heart size, even then the increase in animal welfare is very small. So imagine if they were not doing this sort of explanation and they were doing sign econometrics. They would have given a conclusion that the herd size was statistically significant, so larger herd size leads to increase in animal welfare. Imagine that sort of a conclusion and this sort of a conclusion, right? So in the first case, the over reliance is on statistical significance, but the increase in animal welfare is too small in an economic sense. Okay, that is what matters more to policy, that is what matters more to the theory. So this is how you should develop that skill of talking more about the economic significance rather than talking only about statistical significance. So this entire paper is really well written, maybe in terms of robustness checks, how do they deal about endogeneity issues. So all these things, they have done it very neatly. Okay, they just use OLS. It's not always necessary that you should use an instrumental variable or some fancy models. Sometimes the cure can be worse than the disease itself. So unless the basic model is found to be not satisfactory, then only you should use the advanced method. So you should always start with a simplistic model. So I'll stop sharing now. I'll give the description or the link to the paper in the description, so you can always read it. So to summarize what I have been talking to you in this video, the major take home message is that you should be careful in hypothesis testing, understand what are the assumptions that goes into hypothesis testing. What is your null hypothesis? What is your alternate hypothesis? What is your sampling frame? What is your sampling strategy? Then, while reporting the results, talk about economic significance, make a distinction between economic significance and statistical significance. In reporting the results, give continuous p-values, avoid using stars, talk more on confidence intervals or compatibility intervals. These are the some things which you can do, and I would rather say these are better practices to follow in scientific reporting. I'll also provide you a link in the description which talks about the major controversy surrounding the p-value debate, and also provide some of these tips which I talked about. So thank you so much for watching. Have a nice day.